Hi, welcome everybody. Today we will be going through calculus and the formal definition of derivative. So last time we talked about how to find the tangent line or the tangent slope at a given point on any curve. What I want to do is I want to make that into a formula, so then that way it'll be a lot more effective. So then what that means is instead of having to find the slope at any point of a tangent, like 50,000 times, what I want to do is be able to find like a formula that I can plug it in, so things will be a lot easier, so then that way I don't have to repeat all the process over and over again. So let's just go ahead and do a quick recap first as to what we did last time, and here is an example of it. So for example, find the slope of the tangent line at x equals to 2 for y is equal to x squared plus 3. So the formal definition of derivative, we said that the slope, I guess we can go ahead and denote it as the slope or the tangent slope at x equals to 2, it's going to be one of two ways of solving it. Number one, we can use the limit as h approaches towards 0 of f of 2 plus h and then minus f of 2 all divided by h. So you can see that the stationary point is supposed to be at 2, and we're going to use another point that is going to be of a certain distance away, either from the left or from the right, and then afterward use the equation of the slope to figure that out. Let's go ahead and try to solve for this now. Oh, and by the way, f of x is referring to my equation that's up here. So limit as h approaches towards 0. So f of 2 plus h. So according to my equation, that will be 2 and then plus h quantity squared plus 3. And then minus for the second part, f of 2. So that's 2 squared plus 3, and then all divided by h. Okay, so literally I'm just taking my f and I'm just plugging in x is equal to 2 and also x is equal to 2 plus h. Okay, I'll keep cleaning it up. So limit as h approaches towards 2. As h approaches towards 0. So the top part we get 4 and then plus 4h plus h squared. We have the plus 3 minus 4 and then minus 3 all divided by h. And as we said last time, the indication that you're doing it correctly, all the terms on the top that will cancel out with what's remaining, there should always be an h in the remaining terms. So the 4s can cancel each other out, the 3s can cancel each other out, and again, what's left, they all contain h now, which we can go ahead and divide through. So limit as h approaches towards 0, we have 4h plus h squared divided by h. And when we now go ahead and divide by h, because we can get rid of that problematic part, we have 4 plus h, and we can then use a direct substitution. So finally, as h is approaching towards 0, we can make a substitution. 4 plus 0, the answer is equal to 4. So that's going to be my slope. The other method is the following. We can also say the limit as x approaches towards 2 of f of x minus f of 2 all divided by x minus 2. And so we just go ahead and solve for this factoring problem and simplify as much as possible, and we should end up with the same answer. So if you want to try that, I'll go ahead and leave it to you, but I think we're going to go ahead and skip that for the time being just to save a little bit of time. But nonetheless, here is basically what we've been working with so far in the black. If I want to find the derivative, actually, we shouldn't really call that word just yet because I haven't really introduced it. If I want to solve for the tangent slope, okay, so the tangent slope, okay, at a point x is equal to a, we can go ahead and plug it into what we just did over here. We can have either option 1 or option number 2. Now, what I did right here was I created a new terminology right here called a derivative, and that is basically what we're going to be looking at for this section over here. The derivative, what we can think of it is it's a function of the original function we'll go ahead and call f of x. So in this case, the derivative, we call it f prime of x. And the derivative, in terms of what it does, is it allows us to solve for the slope at an instantaneous point, the tangent slope to be a little bit more specific. So whenever I refer to the word derivative, again, that means it's the tangent slope at whatever given point. So again, from what we've been doing so far, we've always been able to find out what the tangent slope or the derivative is at a single point. Now what I'd like to do is I need to define this derivative, as I said, and then look at it as a function instead of just a numerical value at a single point. The definition of a derivative of a function of f of x is as a function, so you can find a tangent anywhere within the domain. So that's the formal definition. And in terms of how do we come up with this equation, all we have to do is actually take our equation number one, what we've been using so far, and instead of saying the letter a, meaning at a single point, we can just go ahead and replace it with the letter x. So to be a little bit more formal, f prime of x, now the function of the derivative is equal to the limit as h approaches towards 0 of f of x plus h minus f of x, all divided by h. So again, that basically just means that instead of having a fixed point, now we can look at it at any value of x that we want in order to find out what's the instantaneous slope. Okay, so let's go ahead and try now to apply this to the functions that are given, and then we can maybe do a few examples. Here's the first one. Find the derivative of f of x is equal to x cubed minus 5x squared minus 1. Then use it to find the equation of the tangent line at x equals to 2. So as I said, in the past, what we did was we would solve for something like this. The limit as h approaches towards 0 of f of 2 plus h minus f of 2 all divided by h. But now what I want to do is I want to find out what is the slope at any given point and then just plug it into that equation, making it a lot more versatile in that case. Because the problem itself, it might be asking for what is the slope at x equals to 1 after, or what is the slope at x equals to 10 after, and I don't want to reinvent the wheel every single time. So I'd like to get an equation that I could just plug in. So here we go. Let's go ahead and try it now with our approach. And let me see if I can get a bigger eraser here. There he is. Okay. So first, we're going to go ahead and say that f of x is that equation. So f prime of x, basically what I'm trying to solve for, meaning the derivative of f of x, is limit as h approaches towards 0 of f of x plus h minus f of x all over h. So remember, we're not going to use x is equal to 2 just yet. We're just going to look at this as a function first, and then afterward plug it in because we'll just try to get used to this first. All right, so let's see. Limit as h approaches towards 0. So f of x plus h, that is going to be x plus h quantity cubed minus 5 times x plus h quantity squared minus 1. And then we have minus f of x, so x cubed, and then we have minus 5x squared, and then minus 1. Take that whole thing, and then all divided by h. So exactly the same idea, same procedure and everything. Limit as h approaches towards 0. The top part, we're going to have to expand that out. So that's 3x cubed. Oh, sorry, not 3x cubed, my fault. It's just plain old x cubed from what I remember. So let's see, x cubed plus 3x squared h, and then plus 3xh squared, and then plus h cubed. Minus for the 5 plus h quantity squared expansion, that's minus 5x squared. And we have minus 10xh, and then minus 5h squared. And then we also have minus 1, minus x cubed, plus 5x squared, and then we have plus 1. So all divided by h still, okay? And if you don't see how I factor out the x plus h cubed, you can kind of do that on the side if you want. I'm just trying to kind of like go through the faster version of it if possible, okay? So let's see what cancels out here. Let's go ahead and maybe use red for this one. I see the x cubed canceling out. I see also the 5x squares canceling out. I see the 1's canceling out. And just like before, we're now at a position where every single term in the numerator contains h in there, so I can actually divide through. So let's see. If I divide through as well, then we're going to get the following. The first part, actually, let's go ahead and write that out just so you can see everything just in case. So 3x squared h plus 3xh squared plus h cubed minus 10xh minus 5h squared, and all divided by h. Okay, so if I'm going to go ahead and divide through, so now we have 3x squared, and then we have plus 3xh, and we have h squared minus 10x, and then we have minus 5h, and I think that's all of it. Okay, now we can let h equal to 0 by using a direct substitution. So our answer for the derivative function is going to be 3x squared. Anything that has h in there we'll get rid of. So there's the 3x squared, and then there's going to be minus 10x. So there it is. Now that's going to be our derivative function. And again, you're thinking to yourself, maybe, yeah, this is a very tedious one. But again, the first time you see it is always going to be pretty hard. Number two, now we have a function where you can plug in whatever x you want and find the slope instantaneously. So we did actually a lot of the hard work already. And finally, number three, yes, there's an easier way, which I will go over in the near future. Okay, so that is going to be our derivative function that allows us to find a tangent line at any single point. So now the second part says then use it to find the equation, then the equation of the tangent line x equals to 2. So what that means is I'm going to go ahead and solve for f prime of 2. So plug 2 literally into this equation. That will give us 3 multiplied by 2 squared, so that's going to be 12, minus 10 times 2, so that's going to be 20, so that's equal to negative 8. So that right there is going to be our tangent slope at x equals to 2. And sometimes the way that people usually do it also is you can write it like this. You can the notation sometimes that you see is also the following: dy dx, and then we have like a big vertical line, and then x is equal to 2. So these two right here, they basically mean the same thing. So meaning just solve for the derivative of x equals to 2. Okay, you'll see both notations. Let's see, we are not done because I want the equation of a tangent line, so that means that I need the point to work with. At x equals to 2, right, my original function, I'm going to go ahead and plug it in to see what the y value is. I am going to plug it into over here, which is supposed to be x cubed, so that's going to be 2 cubed minus 5 times 2 squared, and then minus 1, because that was my original function. So cleaning that up, we have 8 minus, looks like it's going to be 20 minus 1, so negative 13. Okay, so my coordinate is going to be 2 comma negative 13. And now I have the point, I also have the slope, and that means that we can set up everything. So final answer will be y plus 13 is equal to negative 8 times x minus 2. And that is going to be our final answer then. Okay, so that's going to be the equation of the tangent line at x equals to 2. And you see now what I mean, because earlier I was saying that, oh, what if I now ask you the question, what is the equation of the tangent line at x equals to 1? You don't have to start back from the very beginning. You can just go ahead and start with the derivative equation, plug it in, and then you can just do this small little steps right here. Okay, so it does definitely make it a lot more efficient. All right, let's go ahead and do a couple more examples where the algebra is going to be a little bit different, so you can see how that actually works out then. So here we have f of x is equal to the square root of 5x plus 1, and I like to solve for f prime of x. So let's go ahead and start with the procedure. F prime of x is equal to the limit as h approaches towards 0 of f of x plus h, so that's the square root of 5 times x plus h, plus 1 minus the square root of 5x plus 1 all divided by h. So note that I kind of skipped that first step of writing the formal definition out so I can just do a direct substitution. Save a little bit of time if you can. The tricky here part is that I need to be able to simplify this, so then that way we can get something nice and clean. And the way that you do it, according to algebra, a while back in Algebra 2, we have to multiply by the conjugate of the numerator. So that is to say, the numerator, we have 2 square roots, and it's the difference of it. So we multiply by the sum of those 2 square roots. So hence, that's what I mean by conjugate. So I'm going to go ahead and multiply both top and bottom by 5 times x plus h plus 1, okay? And then plus the square root of 5x plus 1 to both top and bottom, okay? So now all that stuff back in Algebra 2 comes into play, because now you're going to need it for the calculus part. All right. Let's see, the numerator, let's go ahead and write that out after we multiply it out. So let's see, let's go ahead and use red. Limit as h approaches towards 0. And by the way, make sure you write limit as h approaches towards 0 every single time, because then that way you can see that you're supposed to let h equal to 0 as soon as you can plug it in. The top part, that is supposed to be difference of square. So this is going to give me the following. If you have a minus b multiplied by a plus b, that is supposed to turn out to be a squared minus b squared. So what we have is just plain old 5 times x plus h plus 1 minus, in parentheses, 5x plus 1. And be very careful, write that parentheses so you can see that some stuff actually will cancel out. The bottom, we have h times that factor, which I will not multiply out because, again, we like to keep things in factor form when it's simplifying. So then that way, it'll be a lot nicer on the algebra part. So 5x plus 1 over here. Okay. The numerator, I'm going to cross my fingers and hope things will actually cancel out. The top part right here, let's see, we can kind of write it on the side to save a little bit of space. So we have 5x plus 5h, and then plus 1 minus 5x, and then minus 1. So you can see that the 1's do cancel out. The 5x also cancels out, leaving you with just plain old 5h on top. And that's nice because now with the 5h on top, we can cancel it out with the 1 on the bottom. So just kind of write it out one time. So h divided by h times that thing that's inside the square root. So I'll just write comma plus comma, so then that way just save a little bit of time. The h now, the problematic part, cancels from both top and bottom. And all we have left is limit as h approaches towards 0, just what's in the denominator. So 1 divided by the square root of 5 times x plus h plus 1, and then minus the square root of 5x plus 1. Okay. At this point, we can go ahead and let h equal to 0. So we'll go ahead and make a direct substitution. So 1 divided by the square root of 5x plus 1, and then we have minus, and then the square root of 5x plus 1. Oh, actually, I missed something here because this top part is supposed to actually say 5h. So let me kind of sneak that in there. There's a 5 up on top, and then that means that this is a 5. So that means that there's a 5 on the answer on the top then. Okay. So let's see, cleaning that up, we now have 5 divided by the two things on the bottom. That's supposed to be actually the same thing, and there's supposed to be a plus. Ooh, making mistakes left and right. That's not good. 2 times the square root of 5x plus 1. So that's going to be the derivative equation then. Okay. Okay. Finally, part 3. Same style, right? Now let's look at it as a word problem. A particle moves along the straight line with the equation of the motion s of t is equal to that equation. Find and translate s prime of 4. So first of all, they want us to find the derivative equation and figure out what does that actually represent. In this case, remember that s of t represents the particle movement, so it's a displacement equation. So let me kind of just write that out. So s of t is equal to displacement, okay? And that one is a function of time. So if I take the derivative, right, if I solve for s prime of t, what is the slope? Well, the slope is supposed to be, again, the change of y divided by the change of t. So, kind of like change of independent divided by the change, the change of dependent divided by the change of independent. So numerator, again, is going to be displacement. Denominator, that's going to be time. And anytime you say displacement over time, what comes to mind is that it's going to be velocity. So that's what we're actually solving for. And to be a little bit more specific, is the instantaneous velocity at the value of t. So let's go ahead and see if we can solve for this then. First off, s prime of t, we are going to have limit as h approaches towards 0 of s of t. Let's go ahead and replace that. So it should say the following: 1 divided by t plus h quantity squared plus 1, and then minus 1 over t squared plus 1, all divided by h. Okay. Okay, so that looks really, really nasty looking, but I think we can kind of algebra way out of this one, hopefully. What we'll do is, again, an algebra trick that allows us to simplify this as much as possible. I don't like that there are fractions within a fraction, so I need to multiply by something in order to get rid of those minor fractions. And that something would be the LCM. So the LCM being this guy right here and also this guy right here. So what I'll do is in the numerator, I'm going to multiply by t squared plus 1. And then also multiply by t plus h quantity squared plus 1. And that is going to be my LCM, which I will also multiply to the bottom as well. Okay, so there you go. And again, note that I didn't clean up anything in the inside. I just want to keep it nice and factored if possible. Let's see, numerator, if I were to multiply that out, in the first part, the t plus h quantity squared plus 1 factor cancels out. So that leaves you with just t squared plus 1. Minus, for the second part, the t squared plus 1 cancels out. So that leaves you with, in parentheses, t plus h squared plus 1. And then finally, all divided by, again, don't multiply anything out on the bottom, h times t squared plus 1 times t plus h quantity squared plus 1. And if you think about what we've been doing so far, it's usually the case where, again, the numerator, you're going to have all the terms, you're going to have a bunch of terms that will cancel out. And whatever's left over, there's going to be h in every single one of those terms, which then I can divide through by that h. So let's go ahead and look on the side what that numerator cancels out to be, because I want to save a little bit of space if possible. So that's t squared plus 1. The numerator, be careful because you're subtracting the whole factor. Minus, we have minus t squared minus 2th, and then minus h squared, and then minus 1. So again, I'll go ahead and look at what cancels, circling those out. So 1, negative 1, so those are gone. T squared and t squared, good, so those are gone. And again, look, every single term contains an h, so that tells me I'm doing it correctly. So now going back to the very beginning, limit as h approaches towards 0. The numerator, we have negative 2h minus h squared, all divided by h times the first factor multiplied by the second factor, which I'm not going to write out because of just, try not to be repetitive. Okay, so if we divide through, we have limit as h approaches towards 0, just negative 2 on top, minus h, all divided by, now the h is gone from the bottom. So now we have t squared plus 1 multiplied by t plus h quantity squared plus 1. And at this point, I am rewriting the factors because then you can see what happens when you substitute h is equal to 0. So let's see, we can go ahead and do that because now we can use a direct substitution. If h is equal to 0, the numerator will just be negative 2. The denominator, you're going to have t squared plus 1, that's one factor. And then the other factor, it looks like it's also going to be t squared plus 1 as well. So the final answer, I am going to have, oh wait, I think there's something that's missing. Oh, right here, the 2th actually. So no wonder that's kind of funny looking. So let me go ahead and change that over here. Made a small little mistake, but we can take care of that. So let me go ahead and erase this guy. Let me go ahead and erase this guy, and that's probably going to affect this guy as well. So I do apologize. Let's see, go back to this and this right here. Let's see, it was supposed to be minus 2th right there. Okay, so now when we divide by h, we get negative 2t, and then we have minus h, and there we go. So now it actually looks a lot better. And let's see, we let h equal 0, so that's going to be negative 2t on top. All right, now it looks nicer. So negative 2t on top, the bottom part, that's the same thing. So we can say t squared plus 1 quantity squared. So that is going to be our s prime of t. Okay, so that, again, remember, solves for the instantaneous velocity. Instantaneous velocity at some time at time t. And so if I ask you to solve for what is s prime of 4, then that means it's going to be equal to the instantaneous velocity at t is equal to 4. And we can just go ahead and do a direct substitution then. So -2 multiplied by 4, all divided by 4 squared plus 1 quantity squared. So that's going to be -8 divided by, looks like it's 16 and 17 squared on the bottom. So there we go. Okay, so that is going to be our answer. So 289 if you want to multiply it out. All right, so that should do it. And hopefully you learned something from here. I will see you next time. If you like this video, give it a thumbs up definitely.